Perfect. Um, I'm excited because Michael and Carol and others have already kind of given part of the motivation for what I'm going to talk about, so I can kind of talk a little bit quicker. So thank you for that, and thanks for the great presentation. I'm going to describe a little bit about Pachyderm today and how we're enabling machine learning and AI and other pipelines on top of Kubernetes and on top of OpenShift, production pipelines that we have going with people in a lot of different spaces. So I'll describe that a little bit more. What I'm going to do is I'm going to kind of describe as motivation, what a typical machine learning AI pipeline that we see with our users looks like. Some of this motivation, again, has already been given, so I can jump over it pretty quickly. Then I'm going to talk about how that translates down to the Kubernetes layer and what we actually need on top of Kubernetes to enable these sorts of pipelines. And then I'm going to show you a demo of Pachyderm in action with a couple of pipelines, and I hope to leave a bunch of time at the end for questions and answers, because I think that's probably what will be most useful. Okay, great. So let's start talking about machine learning pipelines. So I shamelessly stole David's format from last meeting to illustrate some of these things, just as a reiteration of some of the things he said and some of the things that were actually already said by Michael. A lot of emphasis is put on training and inference when people think about machine learning and AI. And a lot of people are kind of, see the value of AI in their business, but really when it comes down to actually integrating machine learning and AI in their infrastructure and building out, pipelines that can be managed over time and scale, there's a whole lot more that needs to be thought through. And this is really where we see the challenge being. So kind of like David said, in last meeting, there's a whole lot more than training and inference. There's a whole host of things related to pre-processing, feature engineering. There's model export and optimization. There's data transforms when we do inference, possibly post-processing and visualization. And we might not even be using the same frameworks and tools and languages for all of these steps. We could, be needing to mix, TensorFlow and R and Julia, like was mentioned by Carol, because, different teams are building different pieces of this puzzle. And not only that, there's the whole data side of things, which Michael emphasized as well, in the sense that there's actually input and output data associated with all of these different phases of the process that we need to manage. And I definitely see a lot more than I would like to see. People trying to use file names and their own sort of like tooling to figure this out in a not very successful way. Saying, this is my feature set for training from config to with this timestamp.csv that goes into my model training, right? And it's just not sustainable or scalable over time. And in addition to just having those pieces of data, there's an element of actually the sequence that these things are happening in, right? I actually need to move data. So it's not the scenario where I like spin up one environment and I do my training and then I'm done. I actually have to possibly have, environments and toolings for each of these steps and be able to get input data into one step, which produces output data, which goes into other steps, which is utilized by those stages, which has output data, which goes into other steps. And so somehow we both need to manage all of this diverse processing. We need to manage all of this data, and we need to get all of it in the right place at the right time. So this is really what Pachyderm is seeking to do on top of Kubernetes. So in terms of like now transitioning to think about what do we actually need to do on top of Kubernetes to enable this in some sort of sane way. Well, let's say that we just have a couple of these stages that we're dealing with, some pre-processing and some model training, and then we're going to use that model for inferencing. Well, as everyone on this call is kind of a fan of, we know that one way to get these pieces of processing off of our laptop and running in a dependable, reproducible way somewhere else is by Dockerizing these, right? But we don't want to have, people kind of spreading these Docker images out and data scientists logging into a bunch of machines and running Docker run. And this is really where Kubernetes has come up, right? Like we're going to have a bunch of Docker images that we need to deploy on a diverse set of resources. We need to deploy those in a portable way and a reproducible way. And Kubernetes allows us to get those things running on a set of nodes in a very nice way. But actually, if we think about this now, like in terms of the pipeline that we just talked about, these individual stages of processing aren't isolated, right? And they're actually not the only thing that we're managing. We're also managing data, right? So let's say that we have all our data in an object store. So now we have all these pieces. We have maybe our stages that are running as containers, as pods in Kubernetes. We have data. Somehow we need to solve the problem of getting data to the right ones of those pods to run, and then collect the corresponding output from those stages. And we need to do that in a sustainable way. Like Michael was saying, we need to do this in some sort of version controlled way, so that we can actually, remember what we've done, debug what we've done, maintain what we've done, have audit trails for compliance. And somehow we need to string these things together in a series of events. So I want my pre-processing to run on certain data. I want that to output other data, which is used in training, and then maybe that outputs a model which is used in inference. So all of these problems are kind of additional things on top of Kubernetes that we somehow need to enable, similar to, like was already mentioned, solving certain things on top of Kubernetes, like service mesh or like secret management with Vault or something like that. So the things we need to do are get the right data to the right code. We need to process that data on the right nodes. So not only do we need to get it to the right code, in certain cases, we need to use the right types of resources like GPUs and other things. We need to trigger the right code at the right time with the right data, right? So as all of you are aware and kind of trying to enable these, this gets really complicated really quickly. And then if you add on top of that the ability to kind of version your code and data such that you can have full audit trails of everything that you've done, such that you can revert to previous versions of your training data set, such that you can debug and maintain your pipelines. All of this is kind of the extra stuff that we're really concerned with. And so how do we do this? Well, like our solution is Pachyderm. So if you're not familiar with Pachyderm, Pachyderm is this open source data pipelining and data management layer for Kubernetes. So, thinking about like other layers, like was already mentioned, so whether that's service mesh with Istio or secret management with Nomad Vault, Pachyderm is providing this layer on top of Kubernetes that does specific tasks to accomplish these sorts of pipelines. And those things are both the pipelining piece, but also this data management piece. And those things are done together in a unified way. So the different components of Pachyderm that are kind of the core features that enable these sorts of workflows is first data versioning. Like I've already mentioned, we need a way to be able to version our training data sets, our parameters, our visualizations, such that we can both go back in time and run specific processing on specific data for reproducibility. But also we need that versioning, especially as we work on larger teams and we're working with data scientists and data engineers. We, of course, utilize containers for analysis, So this gives us the flexibility to run any languages or frameworks, whether that's TensorFlow or Python or Julia or OpenCV or whatever it is, or just a bash command. Then we want data scientists to be able to develop these stages of processing in whatever languages and frameworks they want, but also to scale those. So we have this concept of distributed pipelines where each stage of our data pipelines are individually scalable. So you can automatically parallelize each stage of a Pachyderm pipeline, and Pachyderm will take care of the data sharding and getting the right data to those workers and then gathering all of the results on the other end. As well, we utilize some of Kubernetes resource limits and requests such that you can very easily schedule, let's say one piece of your pipeline on a GPU node and then another pipeline, parallelized across CPU nodes. And then the final piece that we really think is, one of the unique things that we're striving after, which really only comes when you combine the data management piece with the pipelining piece, is full data provenance. So the ability to say that this particular result came from this particular version of my model, which was trained on this particular version of my training data, which came from these particular versions of my raw data, et cetera, all the way back, no matter how many stages you have. So again, this is important for compliance, whether that's like GDPR or healthcare or finance compliance. It's also just super useful in terms of debugging and maintaining your pipelines over time. Okay, so because this is a technical audience, I definitely wanted to give you a sense of how we actually enable this, and I'm happy at the end, when we're going through question and answer, to give more details on any of these things. But basically, what happens is, again, we have Kubernetes as the foundation for all of this, and a backing object store. Pachyderm, the Pachyderm server, is deployed as a pod on Kubernetes, so it's just deployed like any other application on Kubernetes. And then the user interacts with that PacD, that Pachyderm server, to build pipelines, to version data, to string pipelines together, to pull data out, to push data in, and all of that data, again, is backed in that backing object store. Pachyderm manages all of the metadata associated with those versions and all of that. And then it launches all of the processing stages associated with the pipeline as other pipeline worker pods on Kubernetes. Great. So let me give you a little bit of a sense of what this actually looks like in the real world. So I can go over here. So this is the Pachyderm Dashboard. This is one way to interact with a Pachyderm cluster. So under the hood here, I have a Kubernetes cluster. I have an object store. I've deployed Pachyderm to that Kubernetes cluster, and now I'm interacting with it via our dashboard. There's other ways to interact, via CLI and language client, but this is one way. And you can see here that I've deployed a couple of data pipelines to the cluster. I'm going to start on the right here with the machine learning one, and then I'll emphasize the other one at the end just to kind of illustrate some flexibility. So the first thing that you can see here is that I have these blue icons. So each of these blue icons represents a version collection of data. So here I have a training data set, and in this machine learning pipeline, I'm just kind of doing the hello world of machine learning, the Iris demo. So I have this set, the CSV training data. And if I look at this repo, or actually this one's probably a better example, these are attributes that I'm putting in that I'm wanting to do inferencing on. I can actually see up here at the top some information about this repo that tells me that this is a version collection of data. I can actually have branches of this data. I see multiple commits into this repo. And so I can see that, in a previous state, I actually just had one file here, right? And then in the most recent state, I have two files. So I put an additional file in here. And for any data, for any number of ways that you change the data, all of this is automatically versioned. So that's this first core principle of data versioning. The second piece is around data pipelining and those independently scalable pipeline stages. So that's what these other icons represent here. These are processing stages in my pipeline. Here, this first one, this model stage, is doing model training on that training data set. And then outputting a persisted version of the model. And you can see here that the way that this pipeline stage is defined is just via a Docker image that that my code is running in, and then I'm just running Python code to do this training. And I can show you kind of at the end. I don't want to take time now, but this Python code, it isn't like pulling in any sort of like special Pachyderm libraries or anything. This is the same type of Python code that you would run locally to do your training or in a Jupyter notebook or whatever it is. And then that processing stage produces output. That output is versioned in an output repository on the other side of this pipeline. So you can see here I've output a pickle file that serializes my model. And then I've chained that to the next pipeline, which is inference. And that inference pipeline is just running another Python script that pulls in that model and pulls in those attributes and does inference with the model to produce my eventual results, which are the species of those iris flowers. So one thing to note here is that, like, I have all of this data version, I have these processing stages created. You know, Pachyderm is aware of what data is changing because it's versioning it, right? So actually, if I go over here and I put new data in, so now I'm gonna do this via a second way on the command line. I'm gonna put a file into my attributes repo on the master branch. I'm gonna put this third file. What I'll actually see if I go back here, okay, this is automatically updated, right? So my new file is in that repo, and you can see that I've made 3 commits now. All of that's automatically versioned. Not only that, what Pachyderm was aware that I added some data in that hadn't been processed yet. And so it knew that my results weren't up to date with the current state of my input data. So it actually went ahead and ran this inference pipeline again, and it updated my results such that now I have my third result. So this is kind of how we think about our pipelines. We think about them as kind of DAGs of data, where you put data in the top, and Pachyderm triggers all of the stages downstream that need to run to update your results. The final core principle of Pachyderm that I wanted to emphasize here was that data provenance element. So if you remember, data provenance was the idea that we could tie any specific result, or actually any specific version of data, to all the pieces of data and processing that led to that result. So if I look at this particular inference repo, which is my results, I have 4 commits, okay? And if I look at one of those, I can see that all of the data associated with that, but I can see also all of the upstream commits that actually contributed to that result. So there was training data, there were attributes, there was a master model version that was used in that inference, and there were a couple of specs, and these are the way that your pipelines are defined. So actually, these would represent the processing associated with that particular result. So again, this is definitely something that that we view as very important. The final thing I'd like to emphasize is just that we try to keep this flexible in the same vision as Kubernetes. We want you to be able to deploy this anywhere and scale it on any infrastructure. We also want you to be able to use any types of data and any types of frameworks. So you can see here in this pipeline, just to give you a sense, I'm actually processing image data, right? I'm using OpenCV to do edge detection on that image data. And so this is just to illustrate that, you know, you're not constrained by the type of data or the type of processing. The processing you can use is anything you can run in a container, and the data is anything that can be stored in an object store, which I would say is pretty flexible. We also, so just to kind of circle things back here before we jump into questions, I just wanted to give kind of a couple of future directions that we're going, and also give you some resources where you can find out more. So let me go ahead and present here again. So future directions, we already have deployments on top of OpenShift. We're working on another one, actually, production deploy right now that includes some pretty interesting components. So I'm very happy to be part of this SIG and happy to see things moving forward on that front. We're also really excited to further collaborate with OpenShift and others in the future. And actually, one thing I wanted to draw your attention to is actually just yesterday we submitted a proposal for a little bit more seamless integration between Kubeflow and Pachyderm. And I actually have, we have kind of an example here of running distributed TensorFlow via TF job as a stage of a Pachyderm pipeline. And we're working to kind of improve that functionality as we go, as well as working with people like NVIDIA to better support things like the DGX and other boxes like that. I'll also draw your attention, so I'm going to send out the link to the slides, of course. I would recommend, maybe watching our KubeCon talk. I did a little bit more of an advanced workflow there that included GPUs and TensorFlow. Of course, you can run all of these machine learning examples locally in Minikube and try it out. We have a public Slack channel and docs where you can get help, and of course, anytime, feel free to reach out to me. So I'll kind of quit blabbing at this point and see if there's any questions.
Looks like there's one from Eric. Eric, you want to?
Oh, yeah. Thanks for the demo. That's really cool. I guess you talked a lot about kind of like, when you rev your data, it reruns the DAG, and I was just wondering if you have the sort of corresponding case where, let's say I rev some code in my feature extraction, that also kind of implicitly implies a rerun, right? So
yep, exactly. So actually I can show you that here. So if we go back, if I go back here, this is the job specification that I used for my training. And actually here I have another version of this which doesn't use an SVM model but uses an LDA model. So when you were to update your code, like let's say I ran something, I updated my code, I committed that to Git, all you would have to do is just update your pipeline. And that will, like you said, trigger the exact same thing. So if I look at what jobs are running, oops, sorry for the wrapping here. Go up. That actually automatically started a new job that retrained my model and is rerunning inference with that. Now, of course, that's configurable. Some people don't want to rerun, like if they update their model or something, and that's something that's totally configurable.
Nice. So you showed a lot of kind of push model where it just automatically revs data products for you. So you talked about going back, so probably you can do the pull model where you say I'd actually like to rerun using this particular SHA from the past.
Yep. So each, yeah, you're exactly right. So each of these, if I look at the commit structure, each of these commits in a repo has an ID associated with it. And so you can either reference, if you want the latest from a certain branch, you can just reference that branch name. But you can also reference any commit ID from history to get that particular version of the data. And you can do that either via the dashboard or CLI, but you could also do it if you spun up a Jupyter notebook and used our Python client, you could pull in any version of any data set via that client.
Cool.
Thank you.
Yeah, as Carol has said in the sidebar here, the visuals in this are just wonderful, and I'm quite interested in the topic of data provenance as well. I think that's something that we don't talk about a lot because it's a really hard thing to do. So kudos for getting that into your story and into your workflow. I think that's going to be very important for a lot of the folks that are trying to utilize this. Does anyone else?
Yeah.
Any questions, or is anything further you want to add?
I just had a quick question. Great job, Daniel. Come a long way, which is awesome.
Indeed, yeah. It's been an interesting year. So
yeah. On the data cleaning side, say I've got I'm using an open data set or something, and I'm doing some data cleaning. Is it in the scope of Pachyderm now to track what changes I've made to that data set?
Yeah, so this would be like an open data set that would be stored outside of Pachyderm. Is that basically the question?
Right, yep. Like a government one or something.
Yep. So oftentimes what we see in this sort of scenario, and this actually goes the same for like if you're ingressing data from a database or something like that. What we actually have pipelines that pull in rather than necessarily are driven by pushes. So basically what you could do is trigger that pipeline that would pull in the data from that external source, and maybe save a timestamp associated with that. But then on the output, like it would version your transformed version of that data set as the output of that pipeline. In a similar way, if you were to pull in from a database, each time you make that query to pull the data in, the results of that query could be versioned in Pachyderm. So we wouldn't actively go out and version that whole data set that's stored somewhere else unless you want to pull all of it in. But oftentimes people just kind of version that particular query or transformation of the data set.
That's fantastic. Daniel, I'm looking forward to playing with it.
Excellent. Yeah, reach out. Happy to point you to resources on that front.
Daniel, thanks a lot for that demo. That was awesome. A question regarding, I remember Pachyderm back from the time, but it was certainly not in that awesome state as it is now. Do you have any plans, or do you have anything in the pipeline around serverless? So my thinking was that in the same way that data scientists, would use the notebook to essentially work, that for data engineers and or developers, it would be really cool to have a serverless integration there. And anything functions as a service, doesn't really matter what, probably OpenWhisk, but anything around that.
Yeah, that's a great question. So I'll kind of answer in a couple ways, I guess. So we've added a lot of flexibility in our pipeline spec recently. So that's pretty small. So let me pull this in here. But one of those things that's relevant to this is the scale down threshold that's mentioned here. So you can actually, let's say that you're running batch jobs every once in a while, or you kind of only want to spin up these pods when they need to do the work and then scale them down. So that's really what's meant to or that's what this field is meant to control, in the sense that if you want to spin up 1,000 workers to do some batch processing in parallel, but you only want to do that every Friday, right? You don't want to keep up all of those workers all the time, so you can spin those up immediately and then scale them right back down afterwards. The other thing in terms of services that we have is actually, so this is fairly recent. We just it is included here. So this is the service function is actually a way that you can spin up what you can kind of think of as a long-running pipeline, but it's basically a service that would have access to version data internally, and that you would be able to ping on an internal or external port depending on where you're connecting from. So if you wanted to serve version data or handle version data in some way as a service, that's what this is meant to include. So like I say, this is, I would say, a experimental feature at this point, but it's meant to kind of handle some of these use cases like you mentioned.
Thank you, Dan.
All right, then, if you can put the link to your slide deck in the notes.
Sure.
And I'll add in some of these things. So this has been great for me. I hope it's been really good for everybody else to get this background in here. And I'm really grateful, Daniel, for the insight and the background.